In today's lesson, we're going to talk about how to solve equations that involve absolute value. We're going to first look at the graphical representation, how to geometrically think about this on the number line, and then we're going to talk about algebraically how we would solve them. So let's go ahead and first look at the geometric interpretation. So if I have the absolute value, those bars mean absolute value, remember, the absolute value of x minus a, that represents the distance between x and a on the real number line. So since x minus 0, the absolute value of x minus 0 is just the absolute value of x, the absolute value of x is the distance between x and 0 on the number line. So it's very important that you understand that absolute value is distance. So it's the distance between x and some value a on the number line. So distance, difference. So that's why absolute value is always positive in the end. It's the result of looking at the distance, and distance has to be positive. So again, the absolute value of x minus a equaling c is literally read as the distance between x and a is c units. So let's take a look at an example. So if you're being asked to solve for x, in the following absolute value equation, you're trying to figure out what value or values you could put in for x to make this a true statement. So again, if you remember that the absolute value is the distance between some number x that we're looking for and a, and in this case a is 2. So that's my little starting point on the number line. I'm looking at starting with 2, and I'm looking at the distance being 3 units away. So if I go 3 units this way, where am I? Add 3 to 2, and where am I? I'm at 5 on the number line. If I go 3 units the other direction on the number line away from 2, where am I? I'm at -1. So if I'm looking for the two values, in this case, of x that make this statement true, I see that I have, if I go 3 units to the right, it is 5. And if I go 3 units to the left, it's -1. So let's go ahead and check this. We can actually check this in the original absolute value equation. So I have two values of x that are 3 units away from 2. So I'm going to substitute those in, and I'm going to have -1, the absolute value of -1 and -2. Is that 3? That's the question. And then the absolute value of 5 and 2, is that 3? Well, if I evaluate what's inside the absolute value, I'm going to get -3. And remember, here our input is negative, so what are we really doing? We're taking the opposite. And what does that equal? 3. So it does, in fact, equal 3. Yay. Let's go ahead and do the next one. I have the absolute value of 3. Is that 3? Well, since the input is positive, I just keep it. So yes, this is true. So I have found the two values of x that make this statement true, that solve this absolute value equation. Let's look at the next example. So let's see how we would interpret this geometrically and then solve it algebraically as well. If I'm solving for x in this equation, keep in mind, this is the distance between x and -2. That's how we arrive at that +2 on the inside. So if I look at that, then I see that I have, I'm starting with -2. That's where I am on the number line. And I'm going 3 units to the right and 3 units to the left. If I go 3 units to the right, where am I? I'm at 1. If I go 3 units to the left, where am I? I'm at -5 on the number line. So actually, we now see that we have the absolute value of x plus 2 equals 3. I'm looking for the two values of x that are 3 units away in either direction from -2. There's my solution. Now let's look at the next example. Where am I starting on the number line? Well, keeping in mind that it's difference. So I'm starting at -2, and what distance am I going in either direction? Oh, I'm going 0, so I'm not going anywhere. So I'm staying right here. So what would the solution set be for this one? The solution set would just be, -2. Right? Because I'm not going any distance away from that starting point. Now let's look at the next one. The absolute value of x minus a -2. I'm starting at -2, but what distance am I going? Negative? Can I go a negative distance? I cannot go a negative distance. The absolute value of an expression is always going to give you a positive value. So there is no solution to this equation. There is no x value that I could substitute in there and get a -3 once I take the absolute value. Okay, let's look at the next one. I have the absolute value. Oh, it already is subtraction, so I'm good. So where am I starting on the number line? I'm starting at 1/2. So if I start at 1/2 and I go how many units in either direction? Well, the distance is 4. So I'm going to go 4 units to the right and 4 units to the left. Now, don't freak out. This is a fraction. So we're adding a fraction, and then we're taking 1/2 and we're going in the other direction, so I'm subtracting 4. Now, what do you have to have before you can add or subtract fractions? A common denominator. So I'm going to have to multiply each of these little 1/2s by what? Nothing. But what am I multiplying the 4 by to get a denominator of 2? Well, I'm multiplying it by 2/2. 2/2. So each of those is actually going to be 1/2 minus 8/2 and 1/2 plus 8/2. So what are my two values of x? My two values of x that satisfy this absolute value equation are, well, the result here would be -7/2. The result here would be 9/2. So those are my two values of x. Now, we can always check these, right? We can always substitute back into the equation and make sure that we get a true statement. I'll leave that as an exercise for you. Now, here I'm looking at the absolute value of x. So where is our starting point on the number line? Well, remember, we're actually working with a. A is 0. And then I'm going 3 units to the right and 3 units to the left. 3 units distance. So I'm at -3 and 3. So my solution set here would just be x equal plus or minus 3. Either one would work. Now, let's talk about how we would go about solving these algebraically, okay? So I'm solving algebraically. Well, remember our definition of absolute value. There are 2 cases. The first case is when the input is greater than or equal to 0. You leave it alone. You keep the x. Case 2 is when we're dealing with an x, an input value that is less than 0. What do? We negate it, right? We take the opposite of that input. So really, the only thing that you have to keep in mind, again, is that the output of an absolute value is always positive. So let's talk about this. Here are two cases, and really, there's a quick and nice way to solve these easily. And we're now going to use this dealing with inequalities as well down the road. But let's first look at equations. So remember, case 1 is when our input is greater than 0. So my input to this equation is greater than 0. If the input is greater than 0, we can just drop the absolute value of the original equation, because remember, this is what we're solving for. So I can just drop the absolute value and solve for x. Easy. So what would I do? Add 2 to both sides, and I'd get x is equal to 5, right? Now, what happens when our input is negative? So the inside here is negative. So our first case is when it was positive. Our second case is equal to 0. Second case is when it's negative. Now remember, if the input is negative, we have to take the opposite of the input. So if we take the opposite of the input, we're dropping the absolute value, but we're taking the opposite. So one way that you can really do this quickly is if I divide both sides by a -1, what does this give me? It gives me x minus 2 is equal to -3. So a lot of people quickly take the original equation and drop the absolute value and set it equal to the right-hand side, and then drop the absolute value and set it equal to the opposite of the right-hand side. So then if I were solving, what would I get? I'd get x equal -1. And if you go back, this was the first example we solved geometrically, and we see that our solution set is -1 and 5. So in both cases, during the solution process, there's a point where x minus 2 is isolated on the left-hand side. It is only at that point that you can do the little trick, where you set the inside of the absolute value expression that you've isolated equal to the plus or minus of the right-hand side. So let's go ahead and do a few examples. So if I want to solve for this, I can split it into two problems. One where I just drop the absolute value, or the other case where I have to look at the inside potentially being a negative value. So I can just drop the absolute value, but now set it equal to -3, because that inside could equal -3, but once we take the absolute value, it's positive. So then I'm just going to solve it by subtracting 2 from each, and I do get x equal 1 or x equal -5. Either one of those would work if I were to substitute back in. Now, let's look at the next example. The next example, I have x plus 2 equals 0. Well, I can't negate 0. 0 doesn't have a sign, so I'm just going to drop the absolute value and set it equal to 0. Subtract 2 from both sides, and I get x to equal -2. That's the only solution. Now, looking at the next one, again, this one should alert you. There is something not right here. An absolute value expression set equal to a negative number, no solution. That can never happen. Remember, absolute value means distance. Distance is always positive. Okay, look at the next one. I'm going to split it into two problems. X minus 1 equals 2.5, or x minus 1 could equal -2.5. Solving for x in each equation is going to give me x equals 3.5, or x equals, and do the arithmetic, negative 1.5. This you should be able to do without a calculator. You should be able to do that by hand. Now, in the next example, you should immediately be able to determine, well, x could equal 3 or x could equal negative 3. Those are my solutions. Okay, now the next one is a little bit more interesting. I'm looking at this one and I'm saying, oh, I have a lot of stuff going on the left-hand side. I need to isolate the absolute value expression. So I need to get everything away from that. So how are we going to do that? Well, we're first going to add 5 to both sides. That will give me 2 times the absolute value of x minus 1 equals 8. And then what would we do if we're still trying to isolate the absolute value expression? Divide both sides by 2. And that's going to give me absolute value of x minus 1 equals 4. Now, it is at this point, when I have isolated the absolute value expression, that I split it into 2 cases. So what are my 2 cases? The first one is x minus 1 equals 4, or x minus 1 could equal negative 4. Solving each of those, you should be able to get x equals 5 and x equals negative 3. Each of those values of x would make that a true statement.